Welcome DC-CAS Strategies. We are now Miss McCullough's art room, right here on the 3rd floor.
Yep.
I'm Mr. Kent.
I'm Mr. Athmer, and can you believe it? We only have about 24 hours left before the DC-CAS. We only see you half the time, so that means we only have half the time to see you. So 24 hours, you need to make things happen.
Go blue.
Go blue. All right, so we're going to talk about polygons today, and we are in a fabulous room. We're in the art room. Look how beautiful it is. All the gorgeous paintings.
So many nice colors.
Colors. And I, right now, can see all these polygons taking place in here. Let's come over here, for instance.
Come on over.
I was drawn to this picture, and I see a rectangle. Look at that. How about that? There's a rectangle in the art room. Imagine that. Mr. Kent, do you see anything else?
I see a hand here. That's not a polygon because polygons are made with straight lines.
Yeah, just straight lines.
But if we look at these flags here, we got pretty straight lines here. So another rectangle here on a hand.
What about the stars, too?
Oh, the stars are a polygon?
Stars count as well.
Excellent.
Diane, how do you like polygons in art? Do you use them a lot?
I use them a lot. I use them almost all the time.
Almost all the time. So you can be an artist and be using polygons. You can be a mathematician and use
Awesome.
polygons.
So let's get to the math side of things. Come on over here to our whiteboard. Our good old whiteboard. Let's talk about some vocab first.
Thank you, Mr.
No problem. All right, our first word is polygon. And when we hear the word all the time, but we really need to know what it means. All it is a closed figure with straight sides. A closed figure with straight sides. Squares, triangles, rectangles,
Pentagons.
stars, pentagons, hexagons. Anything you see with straight sides and is closed up is a polygon.
Okay. Also with polygons come a couple of key vocabulary words: interior, exterior. Interior, when you think of interior, ever heard of an interior designer? We're talking about the inside of a home. They're designing the inside of a space. So the interior always deals with the inside. And Mr. Athner, what are we going to talk about when we talk about exterior?
Exterior means the outside. When you have an exterior of anything, you're talking about the outside. So the exterior of a house, you're talking about the roof, the shutters, whatever that may be, outside. Exterior means outside, interior means inside.
Okay, so here are 3 key vocabulary words, and right now, Mr. Athner is going to talk about first the exterior.
Yeah, let's talk about the easy part first. Exterior angles in any polygon. I'm going to draw a triangle. We all love the triangle. Here's a triangle. And when we talk about the exterior angles, we're talking about the angles on the outside of the triangle. And how do you see that? Well, you can extend each line segment and identify all of these outside angles. Here's 1, here's 2, and here's 3. All of these angles are going to add up to 360 degrees. So let's call this angle 1, angle 2, and angle 3. Angle 1 plus angle 2 plus angle 3 equals 108 or 360 degrees. Whoops.
It's okay. Safe space.
Yep, safe space. We're allowed to make mistakes. All right, and the next one, to prove it in another way, let's take a pentagon. If we extend the line segments, looks like a pinwheel, doesn't it? All of these outside angles also equal 360 degrees if you add them all up. So angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5 equals 360 degrees. All exterior angles add up 360 degrees in any polygon.
That's a really interesting fact, Mr. Athner. What I'm going to talk about now, though, is interior angles. And so on this DC-CAS, they may ask you about what is the measure of an interior angle of a polygon, okay? So first things first, we got to make sure we can identify what the polygon is. And so the first step, we need to count the number of sides that we have. So I'm looking here, this looks like a stop sign almost. We got 1, 2, 3, 4, 5, 6, 7, 8 total sides. So I'm dealing with what we call an octagon, all right? Octo for 8, okay? And if we needed to figure out the angles in the octagon, we have a nice, sweet little formula that can always tell us how many angles there are inside of a polygon. And that formula is 180 times n minus 2. And our n, in this case, is the number of sides in the polygon. So we said we were dealing with an octagon because I counted 8 sides, so my n is 8. Okay? And then to figure out what the angles add up to in an octagon, I can use this formula here. So I can say 180 times 8 minus 2. Okay? Remember my order of operations? I'm doing parentheses first, so I get 180 times 8 minus 2 is 6. Okay? 180 times 6, Mr. Athmer, you got a calculator on you?
I don't have it, but let's add them up with our good old handy-dandy extra long hand.
Okay. We get 180 times 6. 6 times 0, 0. 6 times 8 is 48. 6 times 1 is 6 plus 4, a 1080.
So this is a great lesson. Mr. Kent and I, we didn't bring our calculators to art class, but guess what you could always do? You can always write it with good old paper and pencil and use your mental capacity to figure it out.
You got it, Mr. Athner. So my 180 times 6 gets me 1,080 degrees. Okay, remember my degrees here because we're talking about the angles inside of a polygon. So all of these angles add up to 1,080 degrees. But what if this question is asking you, what's the measure of one angle? Maybe they call this angle A. What's the measure of angle A? Well, all of these are equal to each other in a polygon. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8 angles. So really what I can do to find the measure of one angle, angle A is going to be equal to the sum of all my angles, 180 or 1,080 degrees, divided by 8. Okay, so 1,080 divided by 8. Again, I forgot my calculator. So what I can do is I can use long division. So I get 1,080. How many times does 8 go into that? Okay, well 8 goes into 1, that's too big, so 8 into 10, I get 1, 8. Alright, drop down my 8, 8 goes into 28 3 times 8 is 24, subtract that, I get 40. 8 times what equals 40? 8 times 5 equals 40, 135, and so 1,080 degrees divided by 8 is, I get, each angle is 135 degrees here. So angle A is 135, and that looks about right. These angles are obtuse, so they're going to be larger than 90 degrees. Mr. Athman, what are we doing for our final idea of the day?
Our final idea is just identification. So this one's not too bad. We just got to get some terms down. Diagonals, midsegments, and altitudes. So I'm going to draw a good old triangle. Let's make it look like this time. Well, let's talk about altitude first. And when you go in an airplane, which I just did a couple weeks ago, you fly to a certain altitude, also called a height. So your altitude can also mean height. And so when we're looking at the height of this triangle, we're just talking about from one vertex to the other side. And what ends up happening is that has to be a 90-degree right angle to get the exact height of that triangle. So there's the altitude. That's an altitude. All right? Altitude means height. All right, now let's talk about midsegment. Let's draw a green triangle. All right, let's draw one that looks like this. Look at that triangle. What a midsegment is, it means from one vertex, so here are 3 vertexes, to the midpoint of another side.
Ooh.
So let's just say right here, this distance is going to be the same as this distance. So this is our midpoint. Let me label that for you so you don't get confused. It's our midpoint. We can draw a couple more. Here's one of the vertexes. Let's find the midpoint over here. It's about right here. This distance is the same as this distance. So let's connect. And last but not least, here's our last vertex. And let's find the midpoint of this segment right here and connect the two. What do you notice about all the midsegments? They intersect in one spot.
Yeah, wow.
So that is our midsegment. It connects a vertex with another midpoint. And the last but not least is a diagonal. You're very comfortable with diagonals already. Let's use blue. Let's draw a good old-fashioned rectangle. All a diagonal is from one vertex to a non-adjacent vertex. So one that is not right next to it. So this is a diagonal. And let's draw another one, because I see another one. One vertex to a non-adjacent vertex, which means it's not right next to it. I cannot draw a diagonal from here to here.
So, Mr. Athman, real quick, what if I had a pentagon?
Let's draw a
How many
pentagon.
diagonals would I have in a
Let's do
pentagon?
it. So let's draw a pentagon. That looks like a good pentagon, Mr. Kent?
Looks all right.
Let's identify our vertices.
So the vertices are where the lines intersect
Good,
together.
good. Now I got to connect a vertex with one that's not right next to it. So here's one. What about this one? Can't go there, can't go there, but I can go here. All right. Can't go here, can't go here, but I can go here. Uh-oh, it's like a big puzzle, isn't it? Have we got all these? Can't go here, can't go here, but we can go here and also here. Uh-oh, it's starting to look like something we're familiar with. Let's go to this vertex. Can I go here? Nope. Can I go here? Nope. Can I go here? Yeah. What about here? Yep.
Boom.
And boom. Look at that beautiful, gorgeous star. How awesome is that? Art class, mathematics, hey, it all comes together.
Go Blue, you got some practice problems, get to work.